This is lesson 7-2, similar polygons. Similar figures have the same shape but not necessarily the same size. So the shape has to be the same, but the size does not. So one could be larger than the other or smaller than the other. So similar figures have the same shape but not the same size. The symbol that we're going to use for similar is this little squiggly guy. Okay, and two polygons are similar if both their corresponding angles are congruent and their corresponding sides are proportional. So the angles, the corresponding angles have to be congruent because it's going to be the same shape. The shape can't be different. So the angles have the same measure. The corresponding angles are congruent, but the size can be different, so the sides are proportional to each other. So the corresponding angles are congruent and the corresponding sides are proportion. Here's an example of two quadrilaterals, look like trapezoids, that are similar. So I say ABCD is similar to GHIJ. And just like when we talked about congruent, the order of the letters are important. Like angle A is congruent to angle G. You can see they're both a right angle. They're both in red. B is congruent to H. Those are right angles. C is congruent to I. And D is congruent to J. So angle B is congruent to angle G, angle B is congruent to angle H, angle C is congruent to angle I, and angle D is congruent to angle J. The sides are in proportion, so see how AB matches up to GH, and BC matches up to HI, CD and IJ, and AD and GJ. Now, scale factor is the ratio of the corresponding linear measurements of the two similar figures. Okay, so when I write these two sides as a ratio, and we're going to use some numbers, then that's going to be the scale factor of the sides. So let's look at an example. I have triangle ABC on the left is similar to triangle XYZ. So I want to know the ratio of BC over YZ. So I'm going to go to BC. BC is 20. YZ is 8, so I'm going to write that as a fraction, 20 over 8. I'm going to reduce that to 5 over 2 because I just divided by 4. So this 5 over 2 is called the scale factor. So the scale factor is 5 over 2. Each of these sides, AC and XZ, also have a scale factor of 5 over 2. 25 over 10, if I reduce it, is 5 over 2. AB and XY have the same scale factor, so all the sides are in proportion. They have to have that same scale factor. So to see if polygons are similar, I see if their corresponding angles are congruent to each other. Okay, the angles have to be congruent, and then the ratio of the corresponding sides are proportional. Right, so the corresponding angles are congruent, and the ratio of the corresponding sides are proportional. So all of those sides are going to have the same ratio or scale factor. So let's look at an example. I want to see if triangle ABC is similar to triangle EFD. First thing I should look at are the corresponding angles congruent. Let's see, angle A is congruent to angle D right here. Right, so angle A is congruent to angle D. Angle B has 3 little slash marks, is congruent to angle E. And angle C, which has 1 little slash mark, matches up to F. So this one is a little bit tricky because it's turned around, but I still have the corresponding angles are congruent to each other. So since my angles are congruent, yes, that's the first step. Then I have to see if the sides have the same ratio. So I just check all the sides. Now be careful, AB matches up to DE down here. So I have 12 over 15 and I reduce it to 4 over 5. BC is the side with between angle C and B, and that matches up to EF. So 16 over 20 is 4 over 5. AC, which is 8, that corresponds to DF, which is 10, and 8 over 10 is 4 over 5. So all of those corresponding sides have the same ratio. Their scale factor is 4 over 5. Okay, so yes, those triangles are similar because all the corresponding angles are congruent and the sides have the same ratio or scale factor. And then we just have a problem to do. I want to know if ABCD is similar to EFGD, and what's the value of x. So I need to write a proportion. This is a multiple choice question. I want to write a proportion. So let's think about which sides we can use. I want to find x. So x is this side right here, FG. So I'm going to use FG, and that matches up to BC. So I definitely have to use FG and BC. Now I have AB matches up to EF, but I don't know what EF is, so those would not be good sides to use. So I'm going to use this left side, AD and ED. So FG, which is the right side, over BC, which is the right side of the bigger trapezoid, and ED, which is the left side of the small trapezoid, over AD, which is the left side of the big trapezoid. And then I just substitute. So FG was x, BC was 7.5, so I write my proportion. X over 7.5 equals 6 over 9. And then all I'm going to do is cross multiply. So 9 times x is 9x. 7.5 times 6 is 45. And I divide by 9, and I found x. So it would be choice B. And then if you needed to, you could also find y, setting up a proportion using EF and AB and either the left sides or the right sides. Okay, and that's it for today.